Okay. All right. What is meant by a random variable?
No clue.
Variable.
It's random.
It's random.
A value
Oh my gosh.
That's right.
based on the outcome
It's not right.
of a random event. Whoa.
Oh.
All right. So
Oh.
here, I'm going to go through and highlight on this page the ones that I don't want to cover it up. I just want to highlight it. There. 1, 3, 5, 6, and 10 are going to be the ones on this page that you need to know. That's not satisfying.
Oh.
I don't get it. I do it the same way every time and whatever. Okay.
What? Mine just did. Why did it?
All right, so then 3, what information does a probability model give?
The probability of something happening.
It's part of it. It gives all the possible values and their probabilities of occurring.
Test Friday.
How
That's really scary because I don't remember 14 or 15.
Oh, wow.
how do you calculate the expected value of a random variable?
Is this a formula?
NPQ.
No.
Because
Well, it is. Yes, it's a formula. No, it's not NPQ.
Is it the E of X
Not for this
equals
section.
the
E of X
long-
equals
1 over P. I don't know.
That's
Is the E of X equals 1 over P?
All right. In words, multiply
oh.
each possible value. Can't possible. Is that spelled right? Possible. Okay. Value
I think that, yeah, no, that's right.
by the probability that it occurs and then find the sum.
Oh, I did not spell that right. See, I told you that's gonna be my senior quote. I say that like.
All right, the formula, which is really what you need to know. I think this is one of them that on the quiz, I actually say that if you write it, bring it up, I'll check it for you.
Thank the Lord. Ah, that one.
The summation of X times probability of X.
So yeah, it's just saying add up all the values of X times the probability of X. So like the number of times it occurs times the probability of it.
Proud that you know how to say that. I don't.
What? Say what?
So whatever you said of X.
Probability of X.
Is that like a weird 3?
What's the summation?
Also, this next question, this X is supposed to have that over it. It's supposed to be an X bar.
It's supposed to be a mean. What's mean, right?
Huh?
It's not gonna mean.
But specifically what kind?
The X.
I no clue.
Versus these are both mean. What's different about them?
One's just the mean of the. I don't know.
One's a population and one's a sample. Which one's which?
The X bar is the
Bar.
sample.
No.
X
Other
bar,
way, population.
Which one? X bar is what?
Population.
Population.
Try again.
I really thought it was the sample. I was right. Come on, guys.
I just.
All right.
don't
X
know.
bar is the sample mean. Mu sub x is a population or model mean, but I usually just say population mean.
This is the one I can't draw.
Just draw
It's just a
really
U.
curly M.
It's a cursive U.
Just draw M with an exaggerated.
It's true.
10. Given the variance of a random variable, explain how to calculate the standard deviation. So literally just give me the formula for it.
It's the
Square root of
variance.
variance.
Yeah.
So the standard deviation of x is equal to the square root of the variance of x. Anybody still need this one, or can I go to the next one? Are you okay with this one? Beautiful.
We're gonna highlight them first again.
Yeah, this page is 1, 2, 3, 5, and 6. Oh, hold on. I'm gonna do this before I zoom it in. 1, 2, 3, 5, and 6. And it is going to be 8. I don't know if y'all are going to write this one in on 8 on your page, or if you're going to go to the other page. I think I have them both right on both pages, but you'll need 8 as well.
I can tell you of something for number 1. I can tell you 2 things for number 1. 3 things. I can probably tell you all of them. Hold on. Can I?
Don't
Go
they have to
for
be
it.
independent?
Shut up.
I'm,
Oh my gosh. There's only.
no, but
Shut up.
Brooke's like, can I tell you? Yeah, sure. Don't they have to be independent?
No, is that one of them? I thought
Yes.
that was in general.
That is definitely one of them. Well, the other 2
Love
is
that.
Isn't it?
first. Just stop
Ah.
it. I'm gonna kill you.
Well, I mean, you need to hurry up and talk.
There's only 2 outcomes: success or failure.
Okay, so the first one, there are only 2 possible outcomes: success or failure.
The probability of success does not change. Something like that.
2, the probability, what you said is fine. I'm just going to say it slightly different. The probability for success is the same for each trial.
Then the trials are independent.
I thought that was just a thing you had to know, not one of the characteristics.
Not
The
true.
trials are
Dude.
independent.
Still one of the 4 things I knew. It's so mean.
And then just for reference, success is P, failure is Q. Just if you want to have that noted somewhere.
What?
Nothing. I was having a thought.
All right, what is the variable of interest in a geometric model?
Like, what type of variable?
So, like, when would we want to use geometric? When we're looking for what in regards to the observation?
Individual.
What do you mean by that? Because I think you're on the right track,
Yeah.
but it's a little bit
It's
more
the- it's
specific.
the- Wait.
Why
Second.
did you say
I don't know why that was funny, but okay.
Because I said it was because it's supposed to be specific and be.
Oh.
I don't even remember. It's gone.
When I'm looking for the number of observations until what?
Success.
Okay, the first success. So it's the number of observations until the first success. So, Brooke, this is what I was saying we were going to discuss kind of more later. And it's kind of different if you're looking for just like the one thing or you're like adding them all up. That's where the other part of it plays in.
I looked over my notes and homework today. Like, I actually figured it out. So now I kind of understand-ish. Except the ones I didn't get right on my homework, but I still understand.
All right, how do you find the expected value and standard deviation of a geometric variable? So what is the formula for expected value? Actually, here, just for consistency, I'm going to do these in pink so that all formulas will be in pink.
Oh, wow. Way to be cool like that.
1/p.
Yep. 1/p. And then the standard deviation is what?
Is that the square root of n cubed p something?
NPQ? No, that one's just N and P.
The square root of NP.
Square root variance. I don't know.
Is not it? Oh, NP. Square root of NP.
NPQ.
Square root of 1 minus p over p.
Oh,
wow,
my
I don't know
goodness.
this
We
one.
got
That's
that
not
wrong.
what I
Is it,
thought.
so it's only the square root on the top, though?
Hold on. Let me verify something. Yes, but let me verify that. Make sure I don't have it written wrong.
I don't think we ever used that one.
We did not.
Well, so remember how we said technically the top is q. So remember 1 minus p is equal to q because it's either a success or either a success or a failure. So in reality, that top part is q, so it's the square root of q over p.
Oh.
But let me see if I have that. See, that's part of what I would have probably actually done in the notes, which is probably how I would have notated it there.
I think I remember it.
I don't.
The geometric model is 1/p. Yeah, or the other way that's possible that I would have written it, but this is the simplified way. Another way that you may have seen me write it is the square root of q over p squared, where all of it's under, or the square root of q over p. Those are all ways that you could write it. So it's whatever is the easiest one for you to understand is what I would say.
Definitely the first one's easiest.
The first one, you're almost always given your success rate. Like, they're very rarely going to tell you your failure rate is such and such. So the first one only requires you to know success, because then it's 1 minus success over success. Well, the square root on the top.
I'm just like confused myself.
So, yeah, I mean, just saying that's maybe how you saw me write it if I did write it somewhere.
I could have sworn it was in the square root of N, P, and Q.
You're thinking of something else.
So,
That's exactly right.
You're looking at the one for
For the
binom.
binomial.
For one, it's binomial. That's what you're talking about.
Yeah, how do you know when you're supposed to use geometric or binom?
I know.
We'll get there in a second.
Specific.
All right. 5. If x has a geometric distribution, what does 1 minus p raised to the n minus 1 times p represent?
Something complicated.
Failure.
At least. Is it the at
So this would be something written like,
least? Nope.
let me rewrite this and let's see if then you can explain to me. So if this was written like probability of x equal to x equals 1 minus p raised to the n minus 1 times p. What does this indicate?
Success.
Okay, when you want the first success to happen.
Uh-huh.
So you would have, what all this is trying to say is that 1 minus p raised to the n minus 1 is how many failures you get before you have a success.
Okay.
All right, so the next one, what is the difference between a probability distribution function, or a PDF, and a cumulative distribution function, CDF? So hopefully by seeing those names, that helps you. Cumulative means,
More than one.
okay, adding it up. Okay, PDF is just a probability distribution function. So PDF assigns a probability to each value of x. CDF specifically calculates the sum of the probabilities up to X. I'm going to answer 7 just for the sake of helping you out, meaning you should look at it, okay, but just to help you, but that's not one that I'm necessarily specifically pulling from. What is the variable of interest in a binomial model? So with geometric, I'm looking for the number of observations until the first success. So with binomial, what am I looking at?
Just successes in general.
In that amount of trials.
Okay, yes, the number of successes in observations or trials. Okay, so you decide ahead of time, I'm going to run a trial of 50 people, and I want to see how many successes I get in that 50. Okay. Whereas binomial, it would say, up to, how many does it take until I get that first success, not how many I'm getting in a total amount. So that's why I say we probably should go ahead and just highlight it. So for the sake of y'all actually looking at it, I don't want you to ignore it just because it's not highlighted. But it's not necessarily one that there's just going to be a specific question on, at least on the quiz. So then with 8, explain the difference between the binomial setting and the geometric setting.
One asks for the number of trials and the other one does not.
Okay, so for binomial, we have a fixed number of trials. Or observations, okay, and we count the number of successes. And then for geometric, okay, we're looking for how many trials are needed to obtain the first success. So does that help y'all that had the questions about the difference in binom and geometric?
In other words,
For what it's going to be asking you, does that help? Okay. All right, I have to go to a new thingy for the next ones. Do y'all have all of these?
Yes.
Already good? Okay. Just don't want to take it away too soon. Alright, well, 8 was on here, but it's fine. Alright, so I already answered 8. So then 9, let's see. You need to know 9 and 12. And I'm also going to go ahead and answer 10 just so that you have what those things mean. And then I think that's it for, yeah. All right, so 9. So this is going to be more formulas. Okay, so I'm going to switch back to pink. How do you find the expected value and standard deviation of a binomial random variable? So what's the expected value?
N times P, right?
And then standard deviation.
This is the one I said earlier.
NPQ, right? Something like that.
Square root of NPQ.
Thank you.
That's way different from the first time I turned into you.
It is a lot different.
Literally, the first time I turned in, it was just the angle.
But that's okay.
I didn't know.
I'll grade this and try to find you after school.
Okay, thank you.
Alright, so then in the binomial distribution, what do parameters n and p represent?
N is the number of trials, right? And then
P is the probability.
Yep. N is the number of trials. P is the probability of success. I was wondering if he was going to leave the door like partially closed.
We all know what bothers Brooke.
well, it does. Just
And then I know it's not on here, but Q is what?
failure.
Failure.
Okay, probability of failure. Um,
What?
okay,
is that?
this next thing is that combinations thing that I had previously been writing like this. Okay.
Oh, I think I don't know anything.
I am going to explain this to you, but I need to see if it's actually on the quiz.
If it is, I might start crying.
Because no, it's not. Okay. But I do want to explain it to you so that you have it, because the AP like test could give it to you written like this, so I want you to have seen it. But don't like freak out about it. It's literally just what we've been writing like this. N is the number of trials still. Okay, for them, K is the number of successes. We say it as N choose K. So that means you have N things, choose K amount of them, so however many K is. It's called a binomial coefficient. And this specifically tells us the number of ways to arrange K successes in N trials.
Isn't that silly if it says like 5 successes and 7 trials?
Yeah.
But I think in order or anything.
Yeah.
You should also do this on the calculator too.
Yeah, you can do the binomial something.
Yeah, you can. Do y'all know what this means? Or if I told you
Isn't that a factorial?
to tell me the answer to that, would
It's
you
like
be able to tell
5,
me how to
it's
do
very
it?
It's like 5 times 1. Wait, like
No,
5
it's
times
1
4,
times 2
something like that.
times 3 times 4 times 5.
Oh, that's it. Isn't it factorial, something like that?
Yes, it's called a factorial.
How do you know that?
5 times 4 times
did it
3
in
times
her
2
mom's
times
class.
1. Okay, that's what that's equivalent to. So when it means n factorial, okay, this
No, we did
would
not.
be
No, we did. She mentioned
n
it.
times n minus 1 times n minus 2 times dot 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 times 2 times 1. Okay, it's whatever the value is, and you keep subtracting one from it and multiplying them together. Okay, again, it's just something I want you to have seen. You actually can hit the factorial button on your calculator and it will do it for you. But I'm just letting you know in case you see it. That's something
Why
else
does it
that's
become
just
2 times 1?
because I'm just keep subtracting it. Eventually, I have to get down. Like if I had 500, 500 times 499 times 498 times 497 times times 2 times 1. And it's gonna be a very big number. It's gonna be kind of sad, but it's gonna be a very big number
Very. Yeah. This a huge number.
that I have no desire to deal with.
I agree.
Unless it's the amount of money on paycheck.
That